Let's look at how to classify word problems based on the unknown quantity. Last week you learned how to identify 4 basic addition and subtraction word problems. Action word problems have quantities that change. Join word problems have an initial quantity that increases, while separate word problems have an initial quantity that decreases. Word problems that do not have action describe the quantities. Part-part-whole describes a whole and its parts, while compare problems describe 2 different sets to see how much more or how much less between them. This week we'll learn how to identify the unknown quantities in order to further classify these word problems. Let's first look at our action word problems. Join and separate problems contain 3 different quantities. There is a starting quantity, then a quantity that changed in some way. It is either increased for join problems or decreased for separate problems. Then there is a resulting quantity after the change. In join and separate word problems, any of these 3 quantities could be the unknown. Let's look at Antoinette and her books again to help us identify the different quantities within the join and separate word problems. In this word problem, our starting quantity is unknown. The number of books increased when our mom put 2 more books on the table, so that is our changing quantity. The resulting quantity is the number of books on the table after her mom put more there. Now I want you to take a second and think about how you would solve the word problem. Do you think a child would solve it in the same way? The way children and adults think about and solve mathematical problems are different. Adults and older children have more experiences with numbers and have learned relationships that young children have not yet learned. Adults will typically compute the quantities that are known in the problem and isolate the unknown quantity to one side of the equation. This is called a computational equation. Young children typically begin to think about and model the situation based on the sequence played out in the story problem. An equation written in this format is called a semantic equation. Notice that the equation has the unknown in the same location that the starting quantity instead of on one side of the equal sign. Semantic equations are typically written for the action word problems join and separate. Join word problems would list the starting quantity, then add the changing quantity to find the resulting quantity. Similarly, separate problems are written the same way except the changing quantity is subtracted. Since semantic equations list numbers in the same sequence as the story problem, it is easy to identify what the unknown quantity is. Identifying the unknown quantity will help you accurately classify action word problems. Identifying the unknown quantity is how word problems are classified. And as you can see, there are 6 different ways that we can classify our action word problems. The word problem about Antoinette's books can actually be classified as a join, start unknown word problem. Now it is your turn to classify the join and separate word problems in your card sort. Pause this video to write the semantic equation for each of the action word problems. Then write the problem type for each card. Let's look at the join cards first. Card B starts with 7 bunnies, more join in, and the result is 11 bunnies. Since the unknown quantity is the changing quantity, this is a join, change unknown problem. With card C, the unknown quantity is the starting quantity, so this is a join, start unknown word problem. Card G has the resulting quantity unknown, so it is a join, result unknown word problem. Now let's look at the separate cards. Card F starts with 7, some went home and the result was 2 bunnies. This makes card F a separate change unknown word problem. Card K does not have the resulting quantity, so it is a separate result unknown word problem. And card L does not state the starting quantity, so it is a separate start unknown word problem. Word problems that involve no action are a little more difficult for children to solve because it's harder for them to model and act out. Instead of writing semantic equations for the no action word problems, bar models are used. Last week you had a quick introduction of bar models, so let's look at how bar models can be used to help us identify the unknown in no action word problems. With part-part whole word problems, a bar model is used to show the whole in its parts. With part-part whole word problems, the unknown can be described in 3 different ways. First, if we know both parts, but not the whole, it is called a part-part whole unknown word problem. If we know the whole and one part, but not the other part, it is a part-part whole part unknown word problem. The last kind of part-part whole word problems are ones that do not state the quantities for either parts of the whole. These kinds of problems create opportunities for children to think about all the possible decompositions of the whole. For instance, I might have 7 flowers to put in 2 different vases, and I want to know how many flowers could go in each vase. The total number of flowers can be divided up in different ways, such as 1 and 6, 2 and 5, 3 and 4. A problem like this provides lots of opportunities for students to discuss their mathematical thinking. Now pause the video to draw bar models for your part-part whole word problems. Write the name of each part-part whole word problem based on its unknown quantity. When using bar models to identify the unknown quantities, it is very important to label them. Last week, we identified the whole as the number of bunnies and the parts as the number of girl bunnies and the number of boy bunnies. Let's look closer at each word problem to identify the unknown quantity and decide how to name it. Card A provides information about the 2 parts. Since we do not know the whole, this is a part-part whole unknown word problem. Card E provides information about the whole but not its parts. This is a part-part whole, both parts unknown word problem. Card J provides information about the whole and one part. Since the other part is unknown, this is a part-part whole, part unknown word problem. Now let's look at unknown quantities within compare word problems. Remember that compare word problems describe 2 different sets of quantities. The bar model shows how the 2 different sets of quantities are different sizes. Set 1 shows a smaller quantity because the rectangle is smaller. Set 2 shows a larger quantity because the rectangle is larger. The third quantity in this kind of word problem is the difference. The difference can be stated in terms of how many more and how many less. Note that the language of more and less can present a challenge to many children as they're attempting to interpret the relationship between the quantities. Oftentimes they will overgeneralize the word more to mean that they need to add, and the word less that they mean to subtract. This focus on the operation instead of the relationship between the quantities can confuse students. That is why the bar model is a helpful tool for focusing on the quantities instead of the operation. The easiest compare problem is when both the larger and smaller quantities are known and the difference is unknown. Since the difference is unknown, these word problems are called compare difference unknown word problems. Another type of compare problem is when the smaller quantity is unknown. This is a compare smaller quantity unknown word problem. And the last word problem type is when the larger quantity is unknown. This would be a compare larger quantity unknown word problem. Now pause the video to draw bar models for your compare word problems. Identify the larger quantity, the smaller quantity, and the difference. Then write the name of the problem type on each card. Once again, it is very important to label the bar models as you identify which quantity is larger and which is smaller. Last week we identified that in all three compare problems, the number of resting bunnies is the smaller quantity, which is the smaller rectangle, and the number of hopping bunnies is the larger quantity, or the larger rectangle. Problem D states that there are 10 resting bunnies and 15 hopping bunnies. We need to identify what the difference is, so this is a compare difference unknown word problem. Problem I states that there are 10 resting bunnies and the difference is 5. We need to find the larger quantity, so this is a compare larger quantity unknown word problem. Problem 8 states the larger quantity and the difference. Since we need to find the smaller quantity, it is a compare smaller quantity unknown word problem. Make sure that you have all your cards labeled accurately before moving on. Teachers often make assumptions that word problems are too difficult for certain populations of students. However, research has shown that the explicit instruction of word problem structures is beneficial for all students, particularly emergent bilingual students and those with disabilities. In summary, addition and subtraction word problems can be identified in 12 different ways. Examples of each problem type are shown here. You can pause the video now if you would like to take notes on these examples. Next, you're going to practice classifying a few word problems. Mohammed scored 7 points so far in the basketball game. If he wants to score 12 points by the end of the game, how many points does he still need to score? What is the word problem type for this problem? Giovanni needs to bring 24 cupcakes to his class for his birthday. He wants some of the cupcakes to be chocolate and some to be vanilla. How many chocolate cupcakes and how many vanilla cupcakes could Giovanni bring to his class? Go ahead and identify what is this word problem type. "23 children were playing soccer. 12 children were on the blue team and the rest were on the red team. How many children were on the red team?" This is your last word problem to identify the word problem type.